Hey guys, what's up? So in this video, we'll be playing around with the Windows keyboard driver, and we'll be using Windows Debugger, and we'll be attaching it to the Windows kernel, and then we will be analyzing the keyboard driver, and then we will try to modify and play around with the keyboard driver. So without further ado, let's get started. So over here, I have a Windows 10 VM running, and I already have configured a serial port COM1, which I'll be using for attaching to the Windows kernel. And I've already done all the settings that is necessary on the Windows as well. And you could see the mod is chosen as host pipe, and I'm using this particular path for the pipe. And we will be using this path inside our Windows debugger. So now you could see it's actually frozen at a breakpoint because by default, when you enable the debug, it will happen this way. And now you have to go to the debugger and attach to kernel. You could select COM, make sure you checked in pipe, and the baud rate should be the same as what you configured on the VM. So I can show the configuration here. Go to msconfig, and over here in the boot, you could select on advanced option. This is my actual machine. I'm not doing it here. I have done it already inside the VM. So you could select the debug port and select the baud rate and other things, etc. here. And only thing is the baud rate that you selected inside your VM should be matching with the baud rate that you're specifying here. And here, instead of COM1, you should do the pipe. And you can check this if you want, but it's already anyway at the breakpoint. And you can see it's establishing and the connection is established. Okay, now it's at this breakpoint. Now you could give G for continuing with the execution, and you should see Windows booting up. So once the Windows is booted up, and now over here, you could give a control break. So now you could do .cls to clear the screen. Now you can do lm, which will list all the modules, and you could slowly scroll down i8042prt. So if you click on this, you could see this is the driver file, and it will give you a basic information about the driver. So go to the VM. We could continue with the debugging, and we will go to the VM, click on start, and type in device manager. So over here, if you go to keyboard and you go to PS2 keyboard and right click and go to driver details, you could see that this is the driver that is being used. Okay. Now I can show you one more thing. So here, this is the actual controller that is actually used during the early days. The keyboard and the mouse, the entire PS2 controls were done using this particular controller. So if you scroll down, you will be able to see some IO ports that are associated with it. And this is the data port. And this is the port that is used for status as well as commands. That is, if you read it, you will get the current status. And that is, if you are writing to it, it acts as a command register. So any keyboard related data, that is a key press event, everything will be coming. And its corresponding data, that is a scan code, will be coming to this particular port. So there are much more information available within this page, when to read and what is the value to be expected and what is the value to be provided to the command registers, etc. Okay, you could search OSDevWiki and followed by i8042. It's gonna give you this page in the first result of Google. Okay, now I'll break again. You could list all the functions that are present within this module either by clicking here, and you could see it's already executing an examine command or the search command, basically X, and /F will only list the functions. Okay, and what it is doing is it is using the module name and then followed by an exclamation mark and then a wildcard. Okay, so we could just type it in /F i8042 prt exclamation, and if you search for port, and if you search for port, you will see all the functions that are actually having the word port in it. Okay, and what we are interested is in this function. Okay, and you could see this is the address of the function, and you could see what's in the function by using the disassemble or unassemble command. followed by the function name, or you could give the address directly there and specify the length. I don't have to specify that much. I will just specify only 10. And yeah, here you could see this is the function beginning, and you could see it is actually loading a value into dx. Then it is using a special command called in, which is an assembly instruction for reading from an IO port. So if you see, this is our IO port, and you could read and write using in and out instructions in assembly. In instruction is used for reading from the port. Now we will insert a breakpoint over here. You could either use the address or the offset. Anything is fine. Function name plus the offset or the address directly. BP, and you could paste the address, and it should create a breakpoint now. Now, if I go to my VM, unless I'm not, sorry, I forgot to continue. Now that the breakpoint is in place, make sure you're not touching the keyboard, because once you start typing, it's gonna get a breakpoint here. So I'm taking a sticky note so that I could type something. I'm typing A, and you could see breakpoint being hit. So what we could do is, we could just try to print the value that is present in the DX by doing R command, that is to dump the register, and DX, and you could see now the port is actually 64. That is, it is trying to read from the port 64. Okay, and the value will be rendered to EL. That is fine. So we could just press continue. I mean, I'm just stepping to the next instruction, and now it's copying the value from that into this particular pointer location. Now again, so I just continued, and now I'm seeing the breakpoint being hit again. And at this time, I will just dump the value of DX register again, and it's still 64. So I'm just pressing G and pressing enter. And now I'll do the DX again. And you could see now it is actually reading the value from the IO port 60. That is 60 hexadecimal. And that is our data port. That means it's trying to read the data. Now we could step. And now if you try to read the value of AL, you could see it is having a scan code. So now AL is having a value. That is the actual input from the keyboard that it got. It might not be representing the actual key that you pressed. It's not the ASCII corresponding to it. Instead, it should be the scan code. Okay, so I'll open the scan code page over here, and you could see the value in AL was 1E, and that indicates A is pressed. Okay, and similarly, there are 3 sets of scan code. Depending on the keyboard and things, it will change. But I was just saying, this is the value that it will get from the keyboard, and then it has to be mapped into the corresponding ASCII value. That is all done by the driver. We don't have to worry about it. What we are going to do is we'll actually increment its value by 1. That is, if you press A, it will have the value 1E as a scan code, as per my keyboard layout, everything. And when we increment 1, it will give the value 1F instead of 1E. So I actually will press A, it will give the value 1E, we will increment it, and it will become 1F, and the Windows will think we pressed the key S. So that's what we are going to do here. I could just unassemble it here. So here there is a bunch of free space that is available. That is good. And we will replace this return with a compare operation, and we will see whether the DX is having the port 60. Then only we will proceed. Okay. So you could copy this address, and then you can do assemble and press enter, and it will ask you what instruction you want it there. So I'm going to say compare DX comma 60 in hexadecimal. So we should make sure the currently which port is being read is 60. We should not tamper with the data that we are reading from 64. Okay, now it automatically incremented to this location 68, where I'll be doing jump equals, and I could use the function name and plus an offset. Okay, that's actually a short jump plus an offset. I'll give it, it is 260 and 260. I'll give it somewhere here. Any location is fine. So I'll give it 260. So that is 0xc. If the value is equal to 60. Okay. Now you could just simply, if not, we will just return. and I will insert an operation over here. Now we are at 260. Okay, the address to which we are going to enter our instruction is 260, where I'm going to do increment AL, that will increment the AL's value by 1, and we will do a return. Press one more time enter. That should take care of the assembly part. And now you could do unassemble and see whether the things came properly or not. That is, whenever it is reading a value from the port which is mentioned in DX to AL, we will compare whether the port which was read is 60. If it is 60, that means it's a data port. So we will tamper with the data. That is, what we are going to do is we will jump to this particular location and we will increment the AL by 1 and then return. Otherwise, this jump will not happen if it is any other port like 64, and it's going to return from here directly. So now I will just clear the breakpoint and then do G to continue. And you could see the character A getting printed. This is the character for which the breakpoint was triggered. Now if I press A again, you are seeing S. And if I press S, it will print D and so on. It will print the adjacent character on the keyboard when I'm pressing a key. So I could prove it with the help of an on-screen keyboard. So make sure you're using the on-screen keyboard of your host machine, not the VM, because if you're using the on-screen keyboard of your VM, it will not go through the PS2 driver. So now I'll try to clear this thing out, but yeah, none of my keys are working properly as expected. So if I type A, you could see it's S, and if I type S, it would print D. I will select everything together and then start typing Z. You could see X is getting printed. If I press X, Z is getting printed, and so on. So what happens is, if we go to the scan code and if we search for the scan code related to X pressed, yeah, here, X pressed is actually 2D, and we are adding 1 to it, and it will become 2E. And that is the reason why Windows thinks we have pressed C, even though we are pressing X. So here, if you see, whenever I'm pressing X multiple times, it's printing C. So hope you guys enjoyed this video. Thanks for watching. Don't forget to like and subscribe. Thank you.